All right, good morning, good afternoon, good day. How is everyone today? Hey, good afternoon, everybody.
Afternoon.
Hope everybody's doing well. So welcome to spring quarter. And for many of you, this is your last quarter at Clark, so that's exciting. And hopefully everybody has applied wherever they're going if they're transferring in fall. And that should be fun times ahead. Lots of good stuff to learn and good courses and all of that. So so this is CSE223. This wraps up the computer science sequence here at Clark. And will hopefully leave you in pretty good shape to move on to more advanced programming classes, system programming, things like that. And looks like we've got pretty much the entire class here, which is fantastic because this first lecture is super important because we're going to learn Java in the next hour. And then just start building on that for the rest of the course. So I'm going to do a little bit of introduction to the course and some of the aspects in Canvas and such, but mostly we're just going to jump into getting busy with Java, the first ODP, the first programming assignment, which is due on Friday, and getting ready for the second programming assignment, which we'll introduce on Thursday. So, it looks like everybody in here was also in 222 in winter. If I missed someone and that's not the case, definitely let me know so I can set you up with an account on the server. But I think everyone here was also in the winter term. So you should all have accounts on the server. We're going to continue using the Linux server for the one-day programs and for the first few programming assignments. So you should still have access to that. Yeah.
Could I ask you a quick question?
Go for it.
I've been struggling with this a teeny bit. I've used a couple of different Java compilers, but when I tried to use the one on the server, it was a bit older, but I can't quite find that specific compiler.
It should just be Java 8. I think it's the OpenJDK, but it shouldn't really make a whole lot of difference.
I think I was using 11, and I was using the bar keyword, which isn't, I don't think, in Java 8.
Yeah, don't use anything that's not in Java 8, because Java 8's where I'll be grading everything.
Okay.
But are you on Linux?
Yes, I was using a Ubuntu machine.
So you can just download the OpenJDK and dump it into a directory and point to it for, like a Java 8 command or something like that to do Java and Java C with that version if you don't want to, roll back your whole system to 8.
Sure. Thank you.
Yeah, you're welcome. So a lot of people already jumped on the one-day program, which is great. Some people have finished the first programming assignment from the other section, which is also great. We'll get through enough today that you should be able to finish the first programming assignment pretty painlessly, with whatever pain is involved being, sort of the necessary learning curve for switching to an object-oriented language. And it's really not too bad once we get into it. So I'm not going to spend a lot of time going through Canvas line by line. You've seen everything that's in there before. Let me just pop up a few quick things and wave my hands at them. So Tuesday, Thursday syllabus. So again, this is a remote class, so we're planning to meet, every Tuesday, Thursday at this time.
I think we're seeing the wrong screen.
I think I did that yesterday. There we go. All right, how's that?
Perfect.
Fancy. All right. So, thank you. So class meets, same day, same time, Tuesday, Thursdays. Try to come to class rather than just planning on watching the videos. It's 4 hours of videos. They're super dense, especially in the beginning. So unless you really have 4 hours to carve out each week to watch those, it's probably not going to be the same as coming to class. There's a textbook you can download. Pretty much any Java reference is going to work for you, but this is a good open source textbook that you can keep as a reference. Intro to Algorithms by Corman is kind of the gold standard for an algorithms book, but you don't need that. You've got a Linux reference from 224 if you want it. But none of the stuff is brand new or cutting edge. So pretty much anything you find or have on this is going to be good. You can go through the course outcomes. These are the intended learning results from this course. Grading, so pretty simple grading algorithm. So programming assignments, 40%. Right now I've got 6 long programming assignments queued up in Canvas. That's probably all we'll do. That's a total of 40%. Quizzes and one-day programs will be 10%, service learning project 10, and then midterm and final 40% total for those two. And you can click through to engrcs.com as usual for department policies, also for other policies available at Clark, including support services, student support, non-discrimination, Title IX, all of that stuff. You can click through here, and there's links to all of that information. And any questions on any of that or anything else, always just let me know, and I can give you more specific direction. So the syllabus, not terribly different from anything else. Main thing that's new is, the grade breakdown. And ODPs are back. I don't know how many ODPs we'll do. And they'll actually be 2-day programs because of the Monday-Tuesday thing. I'll give, 2 days after the ODP posts for people to finish it. All right, and then additional course policies. So remote class. Again, not required to use your cameras, but if you want a more interactive experience, if you want to feel like you're actually in a class with other people, using your cameras can help. Certainly, interacting in chat can help, but just sort of having a sense that there's other people here besides just a microphone and a speaker can help make it feel a little more connected. Office hours are posted on engrcs.com/schedule as usual. So my hours are basically Tuesday, Thursday, and Friday mornings, 5 hours a week. That's your best opportunity to come and get help, other than asking in class, which is also a great option. Same Discord server is still running. I've seen people on there already. So same situation as before. It's unmoderated. Play nicely. Use it as a resource to connect with people, ask general questions, and so on. But again, it's better if you're not sharing code, because that very quickly gets you into potential trouble with academic dishonesty and things like that. All right.
I posted a bit of my 222 code in.
I saw that. That's fine.
Oh, okay, I'm sorry.
Yeah, no, that's okay. Yeah, more just, stuff for 223 in progress. Let's see. Course preparation. Everybody here has passed 222 with a C or better, so presumably you're in good shape as far as, what are algorithms, what is a program, what's a conditional statement, a loop, and that kind of thing. So we'll be using those kinds of skills going forward. Thank you for the camera. We learned data structures in 222. We're going to be using a lot of data structures, starting with stacks and queues and linked lists today. We'll probably learn some more data structures. We might get into red-black trees, things like that. But we won't necessarily be developing data structures from the ground up as much as using them to do useful things, and that's really kind of where the payoff from 222 is, because we get to take the things that you put all this blood, sweat, and tears into producing and learning, and now you get to just use them. And you know, it's like building a sports car by hand, and now you get to like drive it around and have fun. So late work, everything has to be turned in on time, with the possible exception of the long programming assignments. So PA 1, 2, 3, 4, 5, and you've got a total of 4 slip days, same as in 222. You can use them as you like. You don't have to ask permission or let me know. Just go ahead and you know, turn your assignment in when it's ready to be graded, and I will grade it. And if it came in after the deadline, I'll just record slip days for that. And you've got 4 to use at your discretion. I strongly recommend not using a slip day for the first programming assignment, though, because the second assignment builds on the first, and so you really want to whip through the first one as quickly as possible. Let's see.
A couple of questions about that when we get there.
Yeah, go for it.
Well, I pretty much have it all completely done and running, but I'm trying to print out a line without Java adding a new line.
System.out.print.
Oh, okay.
Yeah, without
So
the
just
ln.
print.
Yeah, without the ln.
Gotcha.
Okay, cool.
Thank you.
Yeah, welcome. Let's see, other policies. I think these are almost verbatim from 222, except kind of this last one. I probably won't be doing a lot of debugging on your code when you turn it in for grading. So really make sure your code compiles and at least does something. If I try to run it and I'm getting syntax errors when I compile, I may or may not spend time trying to fix that. So make sure that what you submit is the correct version. It doesn't have any, you know, last minute typos, things like that.
What about unchecked or unsafe operations? I've had this issue with the Java compilers where I want to compile with excellent to see what I'm doing that's unsafe, but for some reason it never gives me the warnings on what's deprecated. It never sees the argument excellent.
Are you definitely using deprecated features?
I might be. This is really my first bout with the language.
Okay. So if you just say Java C and you're not getting any warnings, you're good as far as I'm concerned. If you are using older stuff and you run a lint check, it should give you, you know, lots of talkback about older features and such. But if you're not getting it, I won't lint your program. So if Java C doesn't complain, you're good to go for grades. But more generally, the lint flag should tell you if something's out of date. Programming style definitely counts. I'm not going to give you specific guidelines, but, you know, put comments in, put comment blocks at the beginning of your main program. If you're writing a function that, you know, does anything interesting, make sure you put stuff in there to explain what's going on, comment your lines of code, so on and so forth. This is not going to be a big deal for our first programming assignment. It will be bigger for our second, and then pretty big for our third.
Do you want us to do the comments in front of the methods like we did with functions in C, or no?
Probably a good idea, except that for this first assignment, you're going to be writing, you know, one-line functions, so I'm not going to worry about having you document those.
Okay.
But for the second one, when we switch these things to classes, yeah, at least, you know, a sentence saying what this method is actually for. Let's see. I think that's all I have in here. Someone mentioned IntelliJ in chat. Thank you. Definitely, I strongly recommend stay far away from IDEs for the beginning of this course. Work from the command line. Work in a you know, terminal window. Compile with Java C. Run with Java. It will help you get in some good habits. It will help you kind of ingrain in yourself some of the standards, some of the ideas, some of the stuff that you're going to write again and again and again, public static void main, etc. So stay away from the IDEs. Eventually we'll switch to Eclipse, probably for some of the graphical stuff we'll do towards the end of the quarter. But life is actually a lot easier from the command line until you start, you know, getting paid by how quickly you produce code, and you have to, you know, write 100 lines of boilerplate stuff around some function. Then an IDE is great because it'll do all that stuff for you. But we'll stick to the command line for now. Lots of cameras on. Good, awesome, thank you. Yeah, nice to see people. All right, so let's talk about Java. And same as my other courses. Any questions come up, don't wait for me to ask. If there's any questions, just go ahead and throw something in chat, or just pop on your mic and say, hey. So let's talk about Java. So the first thing to keep in mind is Java looks a lot like C, and in some ways it acts a lot like C. The syntax is very close to C. The way you make a for statement, a while loop, the types of variables, a lot of that is going to look and feel like C code. And your first programming assignment, which we'll talk about today, is actually mostly writing C, but doing it in Java. But we're not really going to get into like the object-oriented part of Java until Wednesday. So Java and C very similar in some ways, and what you know about C, all the stuff you've been doing in C, will help you in writing Java code. Yeah, so someone pointed in chat, C is actually a language that's been adopted by a lot of other programming languages. I mean, curly brackets and structures of loops and semicolons and things like that. Cuts across a lot of languages. And so Java is the same way. The big difference between Java and C, though, is Java is object-oriented. And we're not going to get too deep into objects right away, but let me give you kind of a high-level overview. In C, if you have a number of pieces of data, we can create a structure, right? We can say something like, structure, student, and then we can say, integer, their ID, and integer grade, and character name, and maybe some other stuff. And then at some point, if we're writing some code that's going to do something with students, we could make a variable declaration, like struct student temp. And I'll put a comment here, temp is a student. And since temp is not, an integer or a character, but it's a structure, I'm allowed to do something like, temp dot grade equals 95. So this is a particular struct student, and I'm setting the grade field equal to 95. Good job, temp. There's a parallel to this in Java, and it's approximate at this point, but basically we can think of this thing as kind of being like a class. A class is sort of like a structure. And this particular thing, which is, a variable of that type, this is kind of like what we're going to call an object. It's a different terminology. The cool thing is that with a class, unlike a structure, in addition to saying, here's an integer, here's a character store, we could also put functions in here. We could say, here's a function called, enroll. And I could say, temp.enroll parentheses CSE223, and it would run some code that's a piece of this structure. So classes are kind of like structures. They're a description of something that's going to contain a bunch of data, but also probably a bunch of code. And then when I make a variable of type, some class, that variable is called an object or an instance of that class. And if I had, a function in here called enroll, I could say temp.enroll, parentheses, and give some arguments in there. And it would run this little piece of code that's sitting inside this structure, or this class. So that's kind of where we're heading. That's a really high-level brief pass over it, but just to kind of keep in mind, because we're going to start tossing around some of these terms. While we're here, let me mention one other thing. We'll toss around the word method a lot. That's basically the same thing as a function. So in C, we use the word method. It means a function. All right. you can find probably whole books on the differences between Java and C, but we'll discover these differences as we go forward. So let's talk about the ODP, because you have an ODP due tomorrow, but this is like a hello world ODP. So let me hop onto the server. And so Canvas, you know, I'll mention when there's an ODP, but it'll refer you to a README. So the README for this is /temp/uppercase README -300. And this is ODP 300, ODP warm up. So that's nice and friendly. And this is just a hello world. So the goal is to write this main program that I'm calling my main, and be able to compile it, execute it, and then assess it. Alright, so this is /tmp/readme -300, uppercase readme. And let's hop into a new window. All right. So one thing about Java to keep in mind, there's some dogma around the language, and there's also some rigid requirements around the language. So one of the dogmatic things is our classes always start with uppercase letters. So this is a class called myMain. I'm going to make an executable program in some sense called myMain. It's got to start with an uppercase letter. It will work if you use a lowercase letter, but people will like throw things at you at work. Because it's just not something we do. We always make class names uppercase. It's a convention, but it's a really, really strongly followed convention. And if you don't follow that convention, people will have a hard time understanding your code. So we're going to stick with uppercase class names. And since I'm making a class called myMain with this exact, you know, structure, I'm going to put it in a file with the exact same name, myMain, but it's going to be .java. And I really want to call my files .java. So let me go ahead and vi mymain.java, and I'm going to be lazy and just copy and paste from here. But it's not a bad thing to, you know, type it in by hand, because you get some practice that way. And it looks like I got a bunch of white space in there. That's okay. All right, so here's my program. We're not really going to get into what all of this stuff means, why we're saying class here, why we're saying public static, void main, string, bracket, bracket, args. We'll get into those details next week. Our goal right now is to be able to write a main program that runs, and then we can use that to start putting instructions in and write whatever code we want, such as, you know, PA1A. All right, so here's our program. Let me go ahead and save that, and then to compile it, we use the javac command. Javac, and then the full name of the file, in this case, mymain.java. So I can type that, and it compiles fine. If I don't say .java, it will complain. So it's not like GCC, where some extensions are assumed. You got to explicitly list the whole thing. And like most things Linux, if it succeeds, it doesn't give you any message. It doesn't say, hey, I compiled your program, right? If you don't get anything output, probably everything is good. If you've got a typo or something, it'll give you some errors. You'll know something's wrong. All right, to execute your program, we can't just say myMain, because this does not compile into executable code. It compiles into something that runs on a virtual machine, and that virtual machine is invoked by saying Java. So to run our program, we say Java, and then the name myMain without the .java extension. So if we say Java myMain, we run it, and it says hello world. All right, so back to the README. back and delete that from the video. Alright, so when you're ready to go, you run your program and it prints out correctly, you can go ahead and assess it. So use the assess command. And the assess command looks a little different in this class. So it's going to be assess space, in this case /temp/mymain-300 space, and then the name of your source file. And there's very little wiggle room on this. So run your assess command, hit the G option to grade, get your 10 out of 10, you're good to go.
Yeah, don't forget the exclamation point.
Yeah. All right, questions about that?
I have a slight question.
Yeah.
In Java, well, in C, we normally have that upper portion on the upper left that indicates like which directory we're needing to pull stuff from, like stdlib and all that kind of stuff. Java doesn't have that?
It does, but we don't need it as much as we need it in C. So for example, we didn't have to tell it, you know, that we're going to use system.out.println, which is, you know, kind of like printf in C. It gives that to us automatically. But if we want to do something with, say, what's called a scanner to do input, we're going to have to put something like an include statement up here. It'll be an import statement, but it'll do the same thing as an include. It'll basically give us access to things that aren't necessarily automatically available.
I had a quick question for you.
Yeah.
So, for the import statement, usually I use the Java util.star. It imports everything from the utility. Would there be any reason why you would want to specify what you want to do in the util?
It's probably better to be a little more tactical about it. Again, you know, kind of looking down the road, if you're in some kind of group development situation where, you know, lots of people are compiling your code, and your code is, you know, thousands of lines long, if you start importing large chunks of libraries, it may slow things down performance-wise. It could get into namespace issues potentially. So it's probably better practice to be kind of as tactical as you can. Quick and dirty, star works fine. Sorry, say again?
It's more of like an efficiency thing for larger, or
an efficiency thing, and not cluttering up the namespace. Because if you include, you know, something that you don't need, and then you want to use something that you're defining with that same name, and maybe you typo it, right, it'll go to the one that you included by mistake. And so I think it's just kind of considered better practice to include just what you need.
Gotcha. Okay, that makes sense.
Yeah.
Is there any equivalency to like a using statement where I could just say I'm using the java.lang.system.out namespace, so I don't have to type in system.out.println every time?
Yeah, so for example, when we import java.util.scanner, we don't have to say java util scanner, we can just say scanner, and it will search, you know, the namespace. We're doing this because this is what's called a static method, and we need to specify the class explicitly.
Oh, that's why.
Yeah, but we'll get to detailed examples of this shortly. All right, so that's your ODP. Go ahead and do that. Get that submitted. Get your 10 out of 10, and you're off and running with 100% in the course, which is great. So let's take a look at what's going on in here. So we made this file called mymain.java, and when we said Java C, it actually created this thing called mymain.class. And mymain.class is a binary file. It's got, you know, some stuff that we can read, but it's not human readable, right? It's pre-digested for a machine to process. And so here's a short overview of what's going on here. We have a source file, which is, you know, like main.java. That's the code we write. That's got our program in it with, you know, public static void main and curly brackets and comments and all that kind of stuff. We're going to compile this using the Java C command. So we compile the source file, and the result of that is what's called a class file. And in this case, it would probably be main.class if I called my class main the way I'm supposed to. And this is a compiled version. The comments are gone. The long variable names are gone. The white space is gone. This is, you know, the binary ones and zeros that a machine is going to be pretty comfortable reading, and that we probably can't make a lot of sense out of. But these are not the ones and zeros that run on my CPU in my laptop. So the CPU in my laptop is an x86 architecture, and it understands, you know, certain ones and zeros to mean certain things. If I was doing this on a PIC processor, the ones and zeros mean very different things. If I do this on a Raspberry Pi, which uses an ARM processor, the ones and zeros mean still other different things. And when we use GCC to compile C code, that creates ones and zeros specific for the hardware CPU that we're running on. Which is why the compiled program that I have on an x86 machine will not run on an ARM machine or a PIC processor unless I recompile it. But the ones and zeros here, these are not made for an x86 or a PIC or an ARM. These are made for an imaginary, a virtual machine called the Java Virtual Machine. And so the JVM, Java Virtual Machine, is a program. And when we say Java, the ones and zeros from this class file basically get loaded into this Java Virtual Machine. And this is the thing that executes and says, you know, oh, here's a 100101. I should initialize something to, you know, 5 or whatever. So Java, go ahead.
Can I ask a quick question?
Yeah.
Are we going to go into, like, during this course, are we going to talk at all about how common language runtimes like the JVM work?
That would be fun, but I don't think we're going to have time for that.
Dang, it's always so nebulous to me how that works.
So this compiles into something called bytecode, and that should be pretty well documented online. I've never really dug into it very far, but it's just another assembly language, another machine language, basically.
The part that confuses me is that they all seem to, like, compile to a virtual machine.
Yeah, so the bytecode that I get for, you know, some main program will be the same no matter what machine I'm running on. It should be the same ones and zeros, which means I can take my class file and I can run it on my laptop, I can run it on a Raspberry Pi, I can run it on, you know, a phone, and it should run just fine. Because on each of those platforms there's a different JVM running, and this JVM, you know, is sitting inside the actual hardware CPU. So it's written in you know, the ones and zeros that my particular CPU understands. But it's an interpreter. It's like Python or MATLAB, right? It reads this file and it decides what to do, and it keeps track in its memory space of the values of variables and objects and things like that.
It seems like there's some distinguishment between, like, the Python interpreter and something like the .NET runtime or the JVM runtime.
Mm-hmm.
But I could be wrong.
So this is a very simplified view of what is much more complex. This is kind of a first order pass at it, but this would be pretty inefficient, right? Because we have this extra layer of abstraction here that's interpreting the ones and zeros. So lots of things are done to, you know, take parts of your program and run it natively, and just-in-time compilation and all kinds of other things like that. The main thing to know here is that, you know, there is a compile step where we convert your source code into some kind of binary code, but there's also an interpreted step. And so some languages are compiled, some are interpreted. Java is kind of both. The nice thing about this, though, is it makes your code extremely portable. I can take something that I've written and developed and compiled and debugged and maintained on one machine, and I can bring it to a totally different hardware platform and it'll still run. And if you're doing anything wrong, you'll discover it really quickly. Because if you're making assumptions about your platform that are not part of how you're supposed to write Java, they'll suddenly jump out at you. So, but stuff will run portably. All right, so we've got an ODP. That's a good start. Let's start writing some more interesting code. So I played around on the server yesterday, and it was kind of being pokey on me. Oop.
Out of curiosity, for this, the first programming assignment, we can add other methods, right? If we want, as long as we have those ones that you specified.
You can, yeah, but I want everything in one class.
But yeah, that's fine.
Yeah. Let's see, I don't need anything from here. Alright, so let's,
Now, I have a question.
yeah.
When you say one class, do you mean a struct or one code page?
So, one file.
Thank you.
And we're going to use the keyword class exactly once, which is going to be up here in the beginning. I'm going to say class main.
It's funny because when you're not putting a bunch of classes in, you're kind of just writing a main program.
Basically, yeah. And this is not the way we want to write Java, but it's the way we're going to do the first assignment, PA1A. And then in 1B, we're going to take that first assignment and rewrite it, reshape it basically into, you know, a proper Java program with classes and objects and so on. But I want to start with, you know, doing something that's pretty familiar to us, which is, you know, writing something very close to a C program. So let's play around with this. We've got our main program, and we already know about print line. All right, so system out print line will let us print a message, and print line automatically puts a new line at the end. If we just do print without the ln, then it does not add that new line at the end. So Java C main Java main, and it says hello. All right, so let's do some coding. Let's make an integer I. And let's just print the numbers from 0 to 9. So compile that, run it, there you go, 0 through 9. We're Java programmers now, congratulations. All right, let's print a table of squares, because, you know, we need that frequently in life. We'd like to know, you know, what's 4 squared, and we can just look it up from a table here. So let's print a table of squares. And this is the first really nice thing that we encounter about Java, is that printing stuff is no longer super painful the way it is in C. So if I were to print, you know, I times I inside my print line, right, there's my squares, but I want to print out something like, you know, 5 squared equals 25. So here's what I'm going to do. Let's print out I, let's concatenate the word squared equals, and then let's concatenate I times I. And these plus signs are string concatenations. And the idea is, you know, squared inside double quotes, this is a string. I'm asking to concatenate I, which is an integer, to this string. Well, you can't add an integer in a string, right? But you can concatenate them if this thing was a string. Well, when I do this, what's going to happen is that a string that represents the value of I will be created for me. If I has the value 5, this will become a string containing 1 character, the digit 5. That'll get concatenated to the word squared. 5 times 5 will be 25, and that will get converted into a string containing 2 characters, a 2 followed by a 5, and this will all get slammed together, and when we compile this and run it, we get our nice table of squares. So this plus operator is definitely your friend, and it saves us from having to do %d and you know, matching arguments and all of that kind of stuff that makes people dislike C. All right. So I'm gonna save this code as we develop it, and I'll push it all over to the Linux server, and you can link to it through Canvas in the shared code area. So let's talk about input. And so when we want to read input from a user, we're going to use something called a scanner. And scanner is going to be kind of the first class that we're going to deal with. So on Canvas, up here under resources, there's a link called Java documentation. And this takes you to Oracle's kind of standard documentation for Java 8. And basically all the classes are listed over here. It's a nice, you know, short alphabetical list of several thousand things. And if you click on one of these, it'll take you to the documentation for that class. So you want to get really, really comfortable with this documentation. You can download this, you can make your own front ends to access it quickly and so on. But you want to rely on this documentation as much as possible. Because this is standardized in appearance. It's also possible to create your own documentation. It looks just like this using something called JavaDoc. And so this is a really good, you know, style of information to get comfortable with. It's kind of like the manual pages in Linux. So standard look and feel. So here's the documentation for a scanner, and I'm going to look at this in my own copy of it because it's a little easier to play with here. So and I've got a doc command that just brings up a manual page. So so what is a scanner? So all of these pages, they have a bunch of information in the beginning that basically talks to you about this in kind of plain language. It also tells you where this comes from. In particular, java.util.scanner. That's where the scanner lives. And so this is where this import business is going to come in handy. So we're going to want to import Java util scanner. And that means if we use the word scanner inside here and we haven't written something called scanner, it will look inside here to find that class. So scanner is a simple text scanner which can parse primitive types and strings using regular expressions. Regular expressions are back. And there's a lot of information in here, right? You can see my progress bar creeping slowly down through the page. We don't need to worry about all of this, right? The main thing we need to know how to do is how to create a scanner. And that's using what's called a constructor. And these are all the different ways we can construct scanners. And then the different methods or functions available in a scanner. And we're only going to work with 2 of these. We're going to work with something called hasNextLine and nextLine. And our goal today is just to read in 1 line of input at a time from the user from standard in. And so hasNextLine will answer the question, is there another line of input available? And it'll return a Boolean, so Java has Booleans, true, false. So we don't have to return integers for true and false anymore. hasNextLine will tell us if there is another line of input available, and if there is, we can call this method nextLine, which returns a string. Java has strings, by the way, so no more character arrays to worry about. And nextLine basically goes past the current line and returns the input that was skipped. So it ingests a line. All right, too much talking. Let's just write some code. So I'm going to make...
The one thing that bothers me about Java is the uppercase and lowercase. It's never like when you can do the int or an integer, and both of them would be either lower or uppercase, and they mean different things, so it's kind of confusing.
So let me mention that right here. That's a good that's a good detail to mention. Something called primitives. So you'll hear people say, and you'll hear me say, everything is a class in Java. Strings are classes. Integers are classes. Linked lists are certainly classes.
Objects of some kind.
Yeah, everything is a class except for a very small number of things called primitives. And the reason is that, to work with a class, you have to do certain things when you construct it. You might have to import certain things and so on and so forth. If you had to do that to say, integer I equals 0, people would rebel. They'd take out their pitchforks and torches and go after Oracle. And people wouldn't use Java. So there are a few exceptions to this notion that everything is a class. And there are these things called lowercase int, lowercase float, lowercase double, lowercase character. And these are called primitives. And they're actually things that aren't classes. They're just plain old primitives like in C. And so if I just want a simple integer I, right, I can get away with just lowercase, int I. But if I want to use the integer class, I could say uppercase integer I, and now I've got something that's not just a simple integer, but it has all these other methods and fields associated with it. So that can get confusing with here, with these types. But that's just for primitives. For methods, for variables, for objects, for things like that, we always start with a lowercase letter, and we generally use camel case. So uppercase the first letter of each word, so it's not just a big long run-on of characters. And then for methods, we make those start with an uppercase letter. All right, so let's
It's interesting. I never thought of it that way, and I didn't know that's the way it was. I always assumed a primitive was, an integer, a float, or an array, or a string of some kind, but it really just means it doesn't have a base object inherit.
Yeah, and I can never remember all the types, but it's an int, a short, a long, a float, a double, a char, a boolean, and a byte, I think, are the 8 primitives. Maybe I can't remember them. Maybe I made it up. All right, so here's all we got to do to use a scanner. Scanner is the name of the class. This is like a variable declaration. I'm making a variable called scan, and it's a variable of type scanner. In Java lingo, this would be an object named scan, which is an instance of the class called scanner. So scan is an object or a variable, and I want to create a scan, right, a scanner. And so I use the keyword new, which you can kind of think of a little bit as being like malloc, but it's not exactly. It's kind of like doing a malloc. So this says, let's create a new object of type scanner, and we can specify arguments. In particular with a scanner, we can say, where do you want to get input from? Do you want to get it from a file? Do you want to get it from a network connection? In this case, we want to get it from standard in, and the keyword for that is system.in. By the way, system.out, that's basically standard out. So this we can just use kind of verbatim for now, and certainly in PA1A we can just use this verbatim. We're going to construct a scanner to read from standard in, and I'm just going to call that scan. You can call it whatever you want. I'm just going to call it scan.
Thank you. I didn't use scan, and I would have been really upset if I had to go back and switch it.
Okay. All right, so we're going to print out a thing that says say something, and now I'm going to do a while loop. While scan dot has next line. All right, so what's going on here? Scan is an object of type scanner. If I look at the documentation for a scanner, there's a method or a function called has next line. You can click through these and get more detail. Has next line returns a boolean. It doesn't take any arguments. All right, I want to know if the scanner that I opened up here has another line. And so I'm going to use the name of that object, scan, and just like if I was accessing a field, right, I'm going to say scan dot has next line, but I put parentheses at the end to say, hey, this is not just a variable, this is a function. So this is basically running a piece of code inside the scanner class. And it's running it on behalf of this object scan, which means, the thing that I opened to read from standard in. And so this has next line will return true if there's more input. And if you read the detailed description, right, this method may block while waiting for input. In other words, if I type one key while my program is sitting here, it's not going to come back from this call. I can type, but I won't come back from this call until I hit enter. Once I hit enter, then this function will return true. If I haven't typed anything, this does not return true or false. It hangs, it blocks, it waits until something happens. If that something is I hit enter, it returns true. If that thing is I hit Control D to signal end a file, then this will return false. Or if I've redirected standard in to come from a file, if there's another line available in the file, this will return true. If I'm at the end of the file, this will return false. So this is like, well, null is not equal to fgets.
I got a quick question with the while loop. So if we have it set up like this, and you said to hit X to exit the program, can you use a break statement for that?
You can use a break, you can use a return, you can do pretty much anything you want.
Okay. So
And yeah, breaks will get you out of while loops, continues will jump you to the top of while loops.
Okay.
Cool.
I just didn't know how to basically tell the program that there is no next line, because you hit X, so technically it sees X as the next line.
Right, so you could, well, scan has next line, or, exit is false, or something like that. There's a lot of ways you can serve it up, but a break's a nice way to get out of a loop. All right, so I'm going to make a string variable called line, and I'm going to say line equals scan.nextLine. And again, if we look at the next line method, right, it doesn't take any arguments, it returns a string. And so this should read the next line of input into this variable called line. And so let's just print out a print message here that says, you said, and let's show what the line is. And then let's go ahead and end the scanner. You want me to turn the volume down? All right. So let's go ahead and run this. Right, this should open a scanner for system in. Ask us to say something. Let's repeat this prompt at the bottom. And we'll read a line, we'll print it out, and then we'll say something more. So the error messages are pretty good for Java. For example, it said there's a problem right here where I said has next line, and it said cannot find symbol, right? So it didn't know what has next line is. Well, it was a typo. It should be an uppercase L. So it's usually pretty good about letting you know what's going on. So let's go ahead and run this. And make sure you don't do what I just did. Make sure if your file is called main2, your class is called main2. So keep that consistent. Alright, so say something. I can say hello, and it says, you said hello. Cool. This is fun. Double space, haha, and so on. Alright, so if I hit Control D, that will signal end of file, and at that point, my loop just exits. And let's be polite here. So there's the end of my loop. let's just say goodbye at the very end. Hello, cool, haha, and then if I hit Control D, it'll say goodbye and we're done. All right, everyone still with me?
We don't have to read Control D.
When you type Control D, this has next line will come back with false. And so hitting Control D causes this to kick out. So yeah, if I run this and I redirect my input from say main.java, right? It read, you know, each line of input from that file because I redirected standard in. It read the last closing curly bracket, and then when it said say something more, Linux basically said that's the end of the file, and so has next line returned false. That kicked me out of the while loop, and then the program said goodbye. Alright, anytime you can get a talking cow into your Java experience, that's good. Alright, so let's modulate this a little further. Let's look at comparing strings. So let's do something a little more interesting in here.
I do love all the built-in methods.
Yeah. Oh, you get totally hooked on this.
So much easier than C.
Yeah, yeah. This is why we do Java after C. All right. So let's do some parsing on the input. Let's say, did they say hello? And if this will not work. Right, so double equal sign still works for comparison, but we cannot compare, you know, a string to double quote hello. It generally will come back false, just like it does in C. Because this double equal sign is basically saying, is this object the same as this object? Not, does this object point to the same set of characters that this object refers to? So we don't want to do this. We have to do something like string compare. Well, it turns out strings are objects. Sorry, strings are classes. And so there's a series of methods available inside strings, including a method called equals. And so equals will take one argument, which is another object, typically a string, and it will look character by character to see if those two objects refer to the same sequence of characters. So the equals method is how we actually see if two strings refer to the same set of characters, even if they're actually different objects. So we can do something like this. Alright, so now we got a program that's going to interact with you a little bit. So we're going to read a line of text using next line. We're going to say if line equals hello, then let's say hello back. Otherwise, we'll just say you said, and we'll just tell you what you said. And then we'll prompt the user again, and then we'll go back up to the top of our while loop and get another line of input. So say something, I can say hi, I can say cool, and so on. But if I say hello, it says hello back. And then if I hit Control D, it says goodbye.
So did you put the new line in front of goodbye because the print statement before that is just a print instead of a print line?
Yes. Yeah,
Okay,
just to
so
force the
we'll just
goodbye to
correct
come
that
out on a
after
new
that.
line.
Okay.
All right. So let's add another command that it knows. Let's see if our line's hello, we'll say hello back. Otherwise, let's see if our line is bye, and if it is, let's go ahead and do a break to kick out of our while loop. Otherwise, we'll say, you said such and such. So compile that, run that. I can say hello, it says hello back. I can say cool, it says you said cool. I can say bye, it says goodbye, and my program exits. So now we're parsing, right? This is input parsing. And most of what you have to do for PA1A is no more complex than this as far as processing the input, because you're processing one character commands: SQ, X, enter, and integers. We'll have to talk about integers in a few minutes. But first, let's talk about functions or methods. Let's modularize our code. So, usually we want our main programs to be pretty simple, and more complex behaviors, we're going to put those in separate sections of code, methods, and we're going to call those and pass information, get information back, and so on. The usual drill for modularizing our code. So let's take all of this business of checking our input, and let's put it in a separate function. All right. So we're gonna do something that I don't like to do, but I'm taking a chance here that it's going to be worth it. We're going to use a keyword called static, and we're going to do this because we're not actually writing, the way that we're supposed to write Java code. We're kind of writing a C program in the language of Java, but we're not doing this in an object-oriented way. In particular, we're doing this all inside one big file, one big class called main4. And because we're doing that, if we want to write a separate function in here, we've got to use this particular keyword called static. And we're always going to use static when we say public static void main, but in general, that's the only time we're ever going to use static when we write Java code until, like week 7 or so of this course. So we're going to use public static void main. That's totally legit. For PA1A, we're going to use the keyword static in front of functions, but after that, we're not going to do that. Okay, so be really careful about that. And there's a really bad rabbit hole you can start tumbling down with static, where you use it once and then the compiler will start complaining that something else needs to be static, and you'll change that, and now it'll tell you 3 other things need to be static, and eventually you end up breaking your Java code and turning it back into C code instead of an actual object-oriented program. So if you start getting error messages after this assignment that talk about static, don't just start putting the keyword static in. It's usually a bad thing to do. Okay, that's my warning. So be aware of that and ask for help if it happens and you can't get out of the rabbit hole.
So since it is a static method, does that mean you don't have to specify public or private?
You could still specify public or private, and I'm not going to bother with that because I'm going to replace the word static with public in the next assignment, and hope that emphasizes the idea of not using static. So that's my trick. But yeah, you could use public or private.
Is Java versatile enough that break statement in that function will still work?
It should, yeah. We will find out. All right, so I'm writing a function called parse, and I'm going to pass it a string, and I'm going to return a Boolean, and I'm going to put a comment here, and I'm going to say return true if the user said bye. And up here, I'm going to change my statement here to if parse line break. Actually, no, I don't want the break down there. I'm going to get rid of that. If parse line break, user said bye. All right. So here's how I'm going to use my function. Right. My main loop is now super slick. Right. See if there's another line. If there is, read that next line. Parse that next line. If parse returns true, that means the user said bye. I'll go ahead and break out of my while loop. Otherwise, I'll say something more. Once I break out of the loop, I'll say goodbye. So now I'm taking the code that was up here and putting it in the separate function, which basically takes an input argument, which I'm calling input, and says, did they say hello? So if input equals hello, I'll say hello back. Otherwise, if input equals bye, I'll say return true. Otherwise, I'll say you said, and I'll echo what the person said, and I'll return false. All right, so everybody see what we're doing here? We've created a function or a method called parse, takes a string, does this business of giving us a response, but also returns a value that tells us whether the person said goodbye. If they say bye, I'll just return true right here. Otherwise, I'll just come down to the bottom and I'll return false. And then I'm using that Boolean up here in this if statement. Parse line will look at the input, respond to it, but it will also return a Boolean which tells me should I break out of my loop.
Just out of curiosity, because I know in Java you can say just if a Boolean, you don't have to specify true or false, it just assumes. Is that the same in C? Or
yeah,
no?
you can say if variable, and if that variable is 0, it'll be false, otherwise it'll be true.
Okay.
You could say, if parse line equals true, but that's redundant, right? So this is good style here, just if parse line. And since it's a Boolean, if it's true, then the if is true, otherwise the if is false. Alright, so let's go ahead and run this. We can say hello, it says hello back. We can say cool, it says you said cool. We can say bye. It noticed that, it returned true, kicked out of the loop and said goodbye, and exited. Alright, for PA1A, you're going to need to deal with integer input. So let's talk about parsing integers. And this is going to come from another class called, guess what, integer, uppercase I. And integer has a number of methods, including this fun method called parseInt. And parseInt will take a string and return a lowercase int, just a plain old integer. So if I input a string from the user, which is what next line returns, I can call parseInt and change it into an actual integer. So let's try this. Let's say enter a number to square. And I'll read a line right here. And by the way, if I want, I can do this. So I can declare my variable on the same line that I'm giving it a value. And I'm not going to bother with, you know, my parse function. So let's convert this to an integer. Alright, so I'll do integer.parseInt with this string as an argument, and that should return an int, which I'm going to save in I. Alright, so I'm going to ask for a number, make sure that there's a line of input available. If there is, I will read that in, save it in the string called line. Use parseInt to convert it to an integer I, and then I'll print out a message. The square of I is, and I'll print out I squared. And then I'll prompt the user again, enter another number to square, and then I'll go back up to the top of my loop, and I'll keep doing this until they hit Control D, and then I'll say goodbye. So this is, you know, so-called junk code. It's not something that someone would pay you for, but it's practice code, right? It lets us work with these different concepts in small pieces. So the only thing we're doing in here that's new is this parseInt business, right? And if something goes wrong, that's where the problem is, and so it's easier to dig into that than doing this, you know, in a 1,000-line program. So enter a number to square 4. The square of 4 is 16. -7. The square of -7 is 49. And then Control D, and it says goodbye. Alright, so we're going to go through PA1A in a few minutes. Actually, I'm going to go through that next. One thing I'll emphasize in there, it's okay if the person types in something that's not an integer in PA1A. You're allowed to just kind of have your program throw up. So for example, if we run this program and they say enter a number to square and you say hi, you get this big long horrifying error message, right, about exception and thread main and all these different things in here, right? That is okay for PA1A. PA1A, you are allowed to assume that the person will always type legal integers. Alright, when we switch to 1B, which is due a week from Friday, we'll go ahead and we'll figure out how to detect if the person types an illegal integer, and we'll handle it gracefully. But for now, you can assume that when I'm testing your program, if I type in an integer, it'll be a valid integer. I won't type in something bogus. And if I do, it's okay if your program just, you know, exits in this kind of ugly way.
Out of curiosity, when you throw an illegal argument exception, does that kick you out of the program, or does that? It does. Okay.
Illegal argument. I don't know.
Like if you code that into, like, you know, else throw an illegal argument exception.
I don't know if that particular exception will throw you out or not. I'm guessing it probably does, but you can look at the description of it. And here's the other thing. So if you look at the parseInt method, right, it tells you it could throw a number format exception. Well, that's what we got. We got a number format exception for the input string hi. Well, what is a number format exception? It's a class, right? And you can read about it in here, and it says, you know, indicate the application has attempted to convert a string to one of the numeric types, but the string does not have the appropriate format. But even your error messages, your errors are classes, and they have, you know, methods available in them, and so on and so forth. So this is that everything is a class kind of mantra. All right, let's take a look at PA1A and get through the specs of that, and then we'll wrap up the last pieces that you need for that, which is basically how to deal with linked lists. And you're not going to have to write linked list code for PA1. We're going to use the linked list class that's built into Java. So this will be pretty delightful.
Is the part 2 where we're gonna make the queue and the stack a separate class, or are we gonna implement our own linked list class?
You're just going to make the stack and the queue a separate class, but you're still going to use the built-in linked list class. You're not going to have to create that yourself.
Gotcha.
Yeah. All right. So programming assignment 1A. This is a full 100-point assignment, but it's sort of half of a larger 2-part assignment. But I want to make sure everyone finishes the first part this week and then works on the second part next week. So you get sort of double points for this one. And this is basically a re-implementation of program 2 from last quarter, so the stack and queue assignment. And so you're going to write a program named PA1A, which means it's in PA1A.java, right? And it's going to let the user type in a few simple commands to say, hey, I want to interact with a stack or a queue, that's an S or a Q, or I want to exit, which is the X command, or I want to remove the top of the stack or the head of the queue by just hitting enter, or I want to add something to my structure by typing an integer followed by enter. And so this will be familiar to you, but there's a sample executable on the server, and you can run it by saying java-cp/temp PA1A. And so, you know, if I hit S, I'm in stack mode, the stack is empty. If I'm in queue, the queue is empty. I can add some things to my queue, and if I type queue, now I can see what my queue looks like. The head of the queue is on the left. It has the first thing that I added, which was a 1. The tail is on the right. That has the 7. If I hit an enter, it'll remove the head of the queue, which was that 1, and now my queue looks like a 2, 4, 5, 7. If I go into stack mode and I push a bunch of things onto my stack, the top of the stack on the left here is the last thing that I pushed. That was a 2. The bottom of the stack on the right is the first thing that I pushed. That's a 6. And you keep both structures, so there's the queue, there's the stack. They remain in memory as I switch, and if I hit enter, I start popping from the stack. So now my stack looks like this, and I can add some things to the top of the stack and see those. And I can go to the queue, and I can add something new to the tail, and so on. And every time I hit enter, it removes. If my queue is empty and I hit enter, it should just say queue is empty. And same thing in the stack, it should pop the stack each time I hit enter. And if I try to pop from an empty stack, it should say stack is empty. And then when you're done, if you type a question mark, you get a help message. When you're done, you hit an X, that exits. So almost exactly the same behavior as PA2 and CSE223, with the one exception that if I type something illegal, my program will just blow up, and that's okay. So I will only use these commands when I test your program. Actually, I don't think I said you have to do a question mark, so I'll just do an integer, SQ, enter, or an X. Alright, so 4 legal commands, or assume the input is an integer. So the structure of the program, your program is going to be a class called PA1A. It's got to be in PA1A.java. Your program, your main program, will create a pair of linked lists. We're going to do this with linked lists, just like in PA1. In PA2 last quarter. So a stack is going to be a linked list, and the top of the stack is going to be right here at the beginning. So when you want to push to a stack, you insert in the beginning of the list. When you want to pop from the stack, you remove the first element in the list and return that, print it out. Our queue is going to be a second linked list. And the setup for this is the head of the queue is going to be here on the left, and the tail of the queue is going to be on the right. So when you insert into the queue, you're going to insert back here. When you remove from the head of the queue, you're going to remove from here.
This might be a stupid question because I don't know if you can do it any other way, but you're able to use all of the Java methods for stacks and queues, yes?
You don't want to. You can, but yeah, you can.
I'm thinking like add and pop and remove and things like that.
All you should need is add first and remove first. But you could do push and pop. But the trick with push and pop is you don't know where it's going to make the top of the stack. Is it going to be here or is it going to be here? And when you print these things, you're going to want to print top of the stack at the left, head on the left, tail on the right. And so you'd like to keep control over how your linked list is built in response to push pop, add and remove.
Okay. If I was able to get it all working properly, is that okay?
Yeah, as long as it works properly and it does the output in the right order, you're good.
I used pop and had no issues either.
Okay, cool. I mean, it should be doing it like this, but. All right. So how are you going to do this? Your main program is going to create a pair of linked lists, and we'll talk about how to do that next. Make a linked list called stack. Make a linked list called queue. Have a Boolean variable that keeps track of what mode you're in. I suggest calling it stack mode. If it's true, you're in stack mode. If it's false, you're in queue mode. In C, you probably did this with an integer variable, and you had one value for stack, one for queue. We can use Booleans in Java. Open the scanner to read from standard in. So we've got that in sample code. And then make a main loop inside your scanner. So while has next line returns true. Read a line of input, right? That's the next line method on the scanner. Parse that input, which means, if the input is equal to X, then do something. If it's equal to S, do something, and so on. If it's not equal to any of these things, how do you know if it's equal to enter? Just see if it's equal to quote, quote. Right? In other words, see if it's an empty line. If it's not any of these things, assume it's an integer, then you can do your parse int to figure out what the integer value is, and then perform the requested action. And to perform the requested action, you're going to make a call to one of a series of methods that you're going to write. So you want to write 8 methods, 4 for the stack, 4 for the queue. Show stack takes a stack, doesn't return anything, and it prints the contents of the stack. Prints TOS followed by each number on the stack, separated by commas inside square brackets. Show queue prints the contents of the queue on a single line with the word head on the left, followed by the head of the queue, the rest of the queue, the tail, and then the word tail on the right. Stack is empty and queue is empty. Take a stack and a queue as an argument and return a Boolean telling you whether or not the structure is empty. Do stack pop, do queue remove, take a stack and a queue, remove the first element from the linked list and return it. And you can assume these are not going to be called if the stack is empty. If the linked list is empty and you try to remove the first element, you'll throw an exception. So in your program, in your main program, before you call do stack pop, check to see if the stack is empty. And if it is, print the message stack is empty. If the stack's not empty, then you can go ahead and say do stack pop. But if the user just decides to keep popping from the stack and they try to pop an empty stack, you should not throw an exception. Alright, and then stack push queue insert, take a stack or a queue and an integer and push it onto the stack or insert it at the tail of the queue. They don't return anything, and you can assume these will not blow up. If the system runs out of memory, these will fail. You don't have to worry about catching that. So your main program is really no more complicated than the main programs we've written so far. You just have to put those different pieces together, right? Open system in, read a line inside a loop, as long as there's more input, parse it to see if it's one of those commands or parse it as an int, and then make a call to one of these 8 methods. If you're in stack mode, you're going to call one of the stack methods. If you're in queue mode, you'll call one of the queue methods. And the only other thing is, you need to have some linked lists to work with. You need to create linked lists in the very beginning called stack and queue. That's what we're going to talk about next. And when we talk about that, you'll discover that these 8 methods you have to write are probably 1 line of code each. You're not going to have to write a lot of code to make a show stack, a stack is empty, a do stack pop, a stack push. These are going to be mostly one-liners. Okay, so if you find yourself writing, 50 lines of code for show stack, you're doing too much work. So one of my mantras is be lazy. That applies extra in this course, right? When we're working in Java or any kind of modern object-oriented language, we don't want to reinvent the wheel. A lot of work has been done out there, a lot of stuff is available for us. We're just going to use that to do more interesting things. So our assignments in here will not be something that manipulates stacks and queues in general. It will be something like something that indexes the words from War and Peace, or something that lets us play tic-tac-toe, or lets us do a networked game with other people. There'll be higher level programs that actually do things that you could explain to people over dinner and impress them, and so that'll be fun. Do we need comments for PA1A? So I want you to stick with good coding habits. I want you to indent. I want you to use good variable names. I want you to comment. I'm not going to give you specific rubrics for that. For this assignment, you probably don't need a lot of comments before these methods, because these are really just wrappers around other things, and these are going to go away in PA1B. But you could have a one sentence comment that says, print out the queue with head on the left and tail on the right, or something like that. All right, and yeah, someone said 6 of these were one-liners, and then the show stack and show queue took more lines. Show stack and show queue will actually be one-liners too. I'll show you how to do that presently.
Neat.
All right, and then submission. Canvas is set to take a .java file, so just upload pa1a.java. If you upload more than once, it will rename it to like pa1a-2 or -3. Don't worry about that. That's fine. The main thing is, your class file that gets defined inside should be pa1a, and I'll rename the main program if Canvas changes the name on me. So that's fine. All right, questions about the goal for PA1A, or the expectations of it. We're going to talk about linked lists next, which will be the last piece of how to do this. But questions about sort of the basic structure or requirements of PA1A.
I have a little bit of a question.
Okay.
When we're talking linked lists and queues and that kind of thing, normally there's a struct and it's going to point to a null and that kind of thing. How is this going to be implemented in Java? Because this is a little different. We're not going to have the struct, correct?
Right. So this is where the idea of an abstract data type will start to come in for real. We're going to use a linked list that's available for us in Java, just like integers and strings and so on. There's linked lists available. And we're not going to have any idea if the last node points to null or it points to something different. We're not going to have any idea if there's a sentinel node or if the list is doubly linked. All of those details are hidden from us. All we're going to see is a linked list that we can create, we can add things to, we can remove things from, we can search, and so on and so forth. And so the details will be hidden from us, as they should be with a good implementation. And so this is going to be a whole lot easier than PA2 was in CSE223 in winter. We're just going to get to use this thing the same way we use ints or strings or files or anything else. And most of the time, once you kind of get past the sort of differences of working with objects, it becomes just the most natural feeling thing in the world. And it's really hard to go back from there to writing C code sometimes.
So I got a quick question. You're going to run these yourself, right? And just test them? They're not going through okay. So if the menu's a little bit different or...
That's fine, yeah.
Okay.
Yeah. Just make sure it's the same commands, so I don't have to like learn a new system because I'll be typing S and Q like 500 times that day. So.
No, that's fine.
But yeah, I grade these all myself. All right, let's look at linked list. Let's do a. I think we can afford a 5-minute break. Let's do a 5-minute break, and we'll come back at 14:37. Okay, a 4-minute break. Yeah, 5 minutes. Really?
Really?
We're going to be rich with emeralds, and it's all because of me. Oh yeah, we're going to be rich with emeralds.
Did you find ore, or are you trading?
I'm going to be trading my vegetables pretty soon.
Cool.
Oh, nice. Yeah, you're inspiring me. I want to do like a rooftop garden somewhere.
Oh,
That would be cool.
Yeah.
come on. This happens every time.
You want another eclair? There's one left for each of us. You should eat it in the kitchen. Okay. Okay. I'll put it on the table for you.
Yeah.
I already ate my second one. I think it's even better than it is in the store because it's colder. It's like, almost tastes like ice cream in the middle to me.
Yeah.
Mm-hmm.
So let's talk about linked lists, and then you got everything you need for 1A. And we are going super fast through Java right now. We're going to slow down after Wednesday. But I want to get you in there writing code and working with it as soon as possible, because that's going to be far more effective than watching me write a bunch of code and then giving you some big long 2-week assignment. So so if this is feeling overwhelming, that's okay. It's intended to be fairly very intense, but you will have all the pieces you need to start working towards a solution after linked lists. So let's talk about linked lists. Linked lists are built into Java. It's a class called, guess what, linked list. So you construct it by just saying linked list. You don't have to give it any arguments. That initializes a list for you. And you have all these methods available. And the main ones we're interested in.
Generic too.
Say again?
You gotta give it a generic too.
Yes, we're going to have to do generics. So the main methods we're interested in, the add method will add something to the end of the list, right? Which is what you want to do when you're making a queue and you want to add something at the tail. Well, you can just use the add method, and that'll put it at the end. When you want to put something in the beginning, like when you're pushing in the stack, you can say add first and put an integer in there, and it will add to the beginning of the list. If you want to remove from the beginning of a list, you can just say remove, and that removes the first element of the list. And if you want to know how many things are in the list, you can say count. Sorry, you can say length. You can say size, and that returns the number of elements in the list. So is the list empty? Call its size method, see if it returns 0. All right, so this is going to be an example of seriously using a class and calling its methods and so on and so forth. So let's make a new program. And we're going to need an import, because linked lists aren't automatically imported. And so if you look at the very top of the documentation, you can see java.util.linkedList. And this, by the way, is a hierarchy. A lot of the ways that the classes are created in Java or other languages is by extending other classes, by starting with some other class and then making some changes to create a new class. And so a linked list is actually part of what's called an abstract sequential list, which is an extension of an abstract list, which extends an abstract collection, which extends an object. Everything is an object, right? All classes are objects, but they're objects with other stuff added in. So we'll play with that in a few weeks, something called class extensions. So I'm going to import java.utility.linkedList. I'm going to make a linked list called myList. Now, there's one other trick here, which just got mentioned by someone, which is the idea of a generic. And here's the idea of a generic. When we wrote linked lists in C last quarter, we wrote a bunch of code, right? And we had to do initialization and follow nodes from one to another and look for nulls and all this kind of stuff. And the fact that we were doing a linked list of integers didn't really enter into a lot of the code that we wrote. The only time that the fact that we were dealing with integers came into play was when we tried to insert in order, and we checked to see if the number we were inserting was less than the next node's data value. But other than that, you know, adding in the beginning, adding at the end, stacks and queues, didn't really make any difference that we were working with integers. If we had decided to make a linked list of doubles, our code would have been exactly the same, except the word int would have been replaced with the word double. And if we decided to make a linked list of strings, the word double would have been replaced with, you know, for C, car star. for Java, just string. And so rather than write, 17 different versions of the linked list class for ints, for strings, for doubles, for floats, this one linked list class is written generically, and it works for lots of different types of objects. And so the way we do that is that when we define a variable or when we construct an object, we put inside angle brackets something called a parameter, and this parameter says what kinds of things are going into this linked list. Okay, that's the long explanation. The reality is all we have to do is this. Put the keyword integer right there, put the keyword integer right here, and we're done. That's all we got to do. If I want to make another linked list, mylist2, I'd have to do the same thing. Linked list integer, mylist2 equals. So you're making two lists, a stack and a queue. You're going to have two statements like this. One for stack, one for queue. But from this point forward, I don't have to say integer because it knows my list is a list of integers. So let's add some integers to the list. So I'm going to add 3 integers to the list. I'm going to add a 10, I'm going to add a 50, I'm going to add a 30. There's my whole program. Alright, it didn't blow up, but it didn't do anything terribly exciting either. Well, actually it did, we just didn't see it. But this created a linked list, which was empty to begin with, and then it added some data to it. It made a node containing a 10, a 50, and a 30. Well, how do we know that? Let's go ahead and let's just say let's just put a print message, my list is, and let's concatenate this linked list to this string. This is pretty cool, right? What does it mean to concatenate a linked list to a string? Well, when we concatenated an integer to a string, I said that the system will take that integer and change it into a string containing the digits representing that integer's value. Well, something very similar to that will happen when we try to concatenate a linked list to a string. So let's see what this does. Look at that. My list is square bracket, comma, space separated list of the values of the linked list followed by a closing square bracket. And the first thing in the list is a 10. That's the first thing that I added. When I said add 50, that got added next. When I said add 30, that apparently got added to the end. So if I look at the documentation for the add method, it says adds a specified element to the end of the list. Well, that's exactly what happened. I added a 10 to an empty list, which made my list look like this. And then I said add 50, which made my list look like this. And then when I said add 30, I put a 30 on the end, so now my list looks like that.
So the end would always be the right of the list?
So the end, the last thing I add would always be on the right, yeah.
Cool.
And we'll talk about on Thursday why this works and how we can use this and how we can make this work with objects of our own creation. But there's something happening which in this case converts a linked list into this particular string. Now we could do this by hand, right? We could make a loop and we could say, let's look at the size of the list, and for each element in that list, let's get that element, and we can treat a linked list basically like an array. And we can say, you know, get element 0, get element 1, get element 2, and we could print those out one at a time, side by side, right? But simply concatenating a linked list to a string turns it into this nice, you know, representation inside square brackets with comma-separated elements. And this is another way to look at abstract data types. Linked lists, we've never used an index with a linked list before. We never wrote code that said, give me the 5th element of the linked list, right? But with a linked list in Java, we can do that. Well, how does that work? I don't know. It could be that our linked list is actually an array, and that when you insert something in the beginning, everything gets copied down one spot in memory, that horrible order n operation, right? Or it could be that this is a linked list like we created last quarter, and when you want the 5th element, it simply follows the links 4 times and then returns the 5th thing on the list. Or, you know, maybe it creates a linked list and it creates an array at the same time. And now when you want the 5th element, it just goes to the 5th element of that array. Or it could be magic pixie dust. We really don't know. And the whole idea is you don't have to know. All you have to know is that these are the methods that you can use to interact with your linked list, and these are the things that they do. And how that happens is hidden from you. And that's an important aspect of object-oriented programming. It's something called information hiding. And so every time that we talked about abstract data types last quarter, this is what we were heading towards, was eventually creating our own classes that will have an interface of methods that a user can use to interact with our data structure, but that will hide information from them related to how we're actually making this implementation work. So that's something to keep in mind. All right, so let's add in the beginning. So if we call the add first method, that inserts the specified element at the beginning of the list. So if I just change this add method to say add first, now when I look at my list, it's a 30 followed by a 50 followed by a 10. Each of these things that I added got put into the beginning of the linked list. Well, hey, we just created a stack, right? We're pushing these things onto a stack. The top of the stack is here on the left. If I call the remove method, without any arguments, it'll retrieve the first element of the list and remove it from the list.
You know, it's apparent that there's some of these methods that are a bit redundant.
Oh yes.
Because pop and remove are basically the same function.
They are. And you know, we kind of did this with some of our stuff in 222. Removing the head of the queue and removing the top of the stack were basically the same function also. But depending on whether you're thinking of this as a stack or a queue or a linked list, you know, you may want to think of this as doing a remove or a pop or a get first, right?
And you know, deprecation also happens, so you may need to leave in older functions that do the same thing.
Right,
for older
right.
code bases.
Yeah, exactly. All right, so let's call the remove method, and I'm just going to put one more statement on here which says remove returns, and I'll see what mylist.remove gives us. So remove return to 30. So let's remove things inside a loop. And we'll just keep calling mylist.remove and printing out the value. So what's going to happen when I run this? Any predictions?
It's gonna print each element and remove it from it.
Mm-hmm. And what's going to happen in the end?
It's going to throw an exception.
Yeah, it's going to throw up probably. There we go. So it removed the 30, the 50, and the 10. But then we got an exception, no such element exception. And it's telling us that happened at line 17. Well, guess what? This is line 17 right here. Well, we can look at the remove method, and if we click on that, it'll tell us remove, hey, it could throw a no such element exception if the list is empty. And we can click through on that and read all about no such element exceptions and so on. So instead of being kind of loose about this, let's say while, well, what would be a good condition to check to see whether it's safe to remove something?
While not null.
Well, not null.
How about while exclamation point my list dot is empty?
That's what I did.
So yeah, so not null is exactly the right idea. But the notion of null is an implementation detail. If we're coding an empty list by being null, that would work great. But we don't know if that's what's happening. And so we could do an is empty, right, which is a method in here. Or we could also do the size, because there's a method size that tells us how many elements are in the list. And so let's do this. Well, my list dot size is greater than 0. And so now once we remove the last thing, my list dot size should be 0, and that should kick us out of the loop gracefully. So there we go. And so isEmpty works because isEmpty is not part of the linked list package, but a linked list is an extension of another kind of class called an abstract collection, and that has an isEmpty method, which returns true if the collection has no elements. And it tells you this implementation returns size paren equals 0, which was, you know, what we could have checked for in here. So yeah, there's almost always a lot of different ways to do things in Java, and that's kind of useful. Don't get tripped up by it, right? If there's a way that should work, if there's a way that makes sense to you, and it works, that's good, right? Unless it's a test and I say make sure you use such and such. But in general, right, there's a lot of different ways to do things. Find something that makes sense to you. And that's usually the best way to do it. All right, other questions? This is a lot of stuff we've got now.
You could be very specific about, in that remove, you could also say the location of it.
Yeah.
Could you do a, like a test run of something like that?
So you could remove from a particular index, right? I could say remove the first element, the third element, and so on and so forth.
First element there.
But if I try to remove element 0 and the list is empty, this will throw an exception. Now, Wednesday we'll talk about how to handle exceptions, how to write our code so that if an exception occurs, instead of, you know, doing all of this, we can simply run a different piece of code in our program and manage it. And so we could, you know, simply try to remove until an exception occurs, or we could check to see if an exception is going to occur and then simply not remove. And we could do that with, you know, removing element such and such. You can also remove an element by value, right? If I wanted to delete the number 10 from my list, I could say remove 10, or, you know, n, where n is equal to 10, and it'll remove the first occurrence of that element from the list. So we can delete from these lists also. And as someone pointed out, remove first is the same as remove. They both remove the first element.
But what is your reasoning against using statics? Because I feel like they're pretty useful for your functional side of your code in these object-oriented languages. Like, you know, quite a lot of them in Unreal are statics. Like, they're function bags of useful functions that you might need to use, but you don't need to instantiate them for anything. Like,
Right, and that's the correct way to use statics. And if you want to create, you know, a bag of functions that you want to be able to use without having to have an object of that class type, then that's exactly when you want to use a static. And so there's nothing wrong with using statics. My warning, though, is that if you start putting the keyword static in where you don't really mean a static, the compiler will generally give you suggestions that will take you down a bad path. And you'll end up making every variable and every method in your class static. And then if you need to create, you know, multiple versions of your class and you try to access those static methods from an object, it'll complain that it's, you know, a static from a non-static reference. And then you start undoing it and it just becomes this big quagmire. And we're not going to need to make, you know, static methods or static variables for the first few assignments at least. So if you know what you're doing, yeah, no problem at all using those. My disclaimer is just that, you know, because we're using static in this first set of examples, I don't want people to think that you always have to put static in the front of a function, because generally you don't.
Somewhere you don't need to.
Yeah, exactly.
So I have a quick question.
Yeah.
Regarding the public and private. So obviously I understand the concept. Public means that everything in the file can access that method, and private means only in that class. But is there, I was told there's an exception to that where you can actually access a private method if you code it correctly. Like if you need just one method.
So you can use protected. That's kind of in between public and private.
Other classes can access your protected methods, but outside things cannot.
Right.
Yeah, okay.
And you know, if you're writing code for yourself, usually you can just leave off the scoping, and the defaults are acceptable. But if you're writing code that's going to be used by other people as part of larger projects, then you want to pay more attention to the protection on the namespace.
Well, I was kind of going through this because in the last class that I had was more of an advanced Java, and so I was really kind of learning the basics in there.
Okay.
And they would give us a lot of code from like UW Java classes,
Mm-hmm.
you know, and so it would say here you need to write these methods to interact with these code, you know, this code.
Mm-hmm.
And so there was a few times where I needed a certain variable from a private method in a separate class in order to do things a little bit easier, but ended up obviously not being able to do that because I didn't really know 100% what I was doing the whole time.
Okay.
Are you trying to like get at like private set public gets for variables?
No, mainly it was, and I don't want to get too much into it, but it was a shopping app basically, and the grid and the GUI was all set up for us, but we had to write what it was actually doing in the back end. And so there was a couple, I can't remember exactly what it was, but there was a couple things in the GUI code that I could have accessed and would have made life 100 times easier.
Okay, yeah.
But it was a private method, so I wasn't able to do that.
Right.
And I can't change his code because he's not linking. You know,
Okay.
he's linking his own stuff.
So we'll talk about accessors and mutators at some point, which is one way to do some of what you're describing, which is to have, say, a private variable but still allow people to do controlled access to it. And if somebody doesn't provide, you know, accessors or mutators, and somebody outside needs to interact with those variables, right, you're kind of out of luck. But maybe you can extend the class and make your own, and then go with it from there.
Is there any way to like have like getters and setters that you don't like manually have to program? There's like in C# it'd be you declare a variable name and then you give it a couple of curly braces, private or public for set.
Mm-hmm.
does some defaulting from private most to public most.
I don't think that's part of Java, but you know, if you're using an IDE, it's usually like 2 clicks and it'll write setters and getters for you for a variable. Again, it's kind of good practice for people who are new to Java. It's kind of good practice to write these things yourself so that they're not mysterious things that just appear. But a good use of IDEs is a lot of stuff that we tend to write over and over and over again that we don't really need to put a lot of our own personality into. We can get the IDE to do it for us. Like writing system.out.println, right? There's not a whole lot of my personal flair in that set of symbols, right? So I'm okay using a keyboard shortcut to make that appear in my file, or you know, get variable, set variable, that kind of thing. But IDEs tend to do too much of that for people who are learning a language. They do things that you really need to learn, and they just make them happen. And then, you know, your code works, but you don't really understand it. So that's why I say stay away from IDEs for now. All right, so linked lists in PA1A, right? So your program structure, your main method should create a pair of linked lists of integers. So that's just going to be, you know, linked list curly bracket or angle bracket integer. Make one called stack, one called q. So do this twice, one for a variable called stack, one for a variable called q. And then, you know, Boolean variable to keep track of the mode you're in, that's fine. Scanner we've done, and so on. So let's look at these required methods, right? Show stack. Well, show stack is just a print method, right? System.out.println, quote, TOS arrow plus stack plus, you know, well, plus nothing. Just this string plus stack. And stack will get turned into that string of square brackets with the first element on the left and each of the elements separated by commas. And since this doesn't return anything, since this is just supposed to print the contents, and this is also unusual. Normally we don't print from methods, right? We print from a main program, but in this case I want you to actually print from the show stack method. So it's just one print line method. System.out.println quote TOS plus stack. That's it. How do you print the q? System.out.println quote head arrow plus q plus quote arrow tail. How do you tell if the stack is empty? Well, stack is a linked list, so we could say, you know, if stack.size equals 0, return true. Else return false. Or we could, you know, simply return stack.size equals 0. And if my stack is empty, this will be true, I'll return true. If the stack is not empty, this will be false, I'll return false. So that's another one-liner. Q is empty, exactly the same thing. It's just a linked list. See if the size is 0. Do stack pop, well, we want to remove the first element from the list and return it. That's just return stack.remove. Do Q remove is just return Q.remove. Stack push is just stack.add first, parentheses num. And this is Q.add. We want to add to the end of the queue because that's where the tail is. So we can use add, which appends to the end of the list. So this is just Q.add parentheses num. So these are wrappers around methods in the linked list class. And the main work you have to do is writing your main program. And that will take a little bit of doing, but it's a good way to get more comfortable with the scanner, with doing print statements, with checking to see if strings are equal to each other, with, you know, doing your conditional statements and if else's and so on and so forth. But nothing that I expect is going to give anyone here a great deal of difficulty. I don't know if I'm going to do an ODP tomorrow. Probably not, because, you know, PA1A is due on Friday. I really want people to spend their time with that. and it's kind of like a super duper amped up ODP in some sense, but it's a 4-day program, you know. But I'll probably start back ODPs next week, and I'll generally post them on Mondays and Wednesdays, which means you'll have a day to look at them and then ask in class or office hours, and then another day to work on them. So there'll be 2 days instead of 1. All right, any other questions? So yeah, no size ofs to worry about in here, no mallocs to worry about in here. This new keyword basically does all that heavy lifting for us. When we say new linked list, it basically finds memory and sets it aside and does some initialization perhaps, and then just returns a reference to that chunk of stuff in memory.
Yeah, I don't even think Java has pointers or anything, if I'm right.
Yeah, so you sometimes get a null pointer exception, but yeah, we don't deal with pointers directly, which is nice.
That would be just like using the next method, right, or first occurrence or that kind of stuff. You're kind of pointing to an element, right, in a list.
Mm-hmm.
But you're not really using a pointer.
Yeah, so we're really just going to be thinking about objects, and for the sake of getting into the mindset of objects, you can kind of think of this my list as, you know, kind of a pointer to a linked list. But we'll move away from thinking about the pointer part of that pretty quickly. I'll sometimes say it's a reference to a linked list, and that's fairly accurate-ish.
It's a pointer you don't have to directly touch.
Definitely.
Which is cool.
It is cool. So I think by and large people will enjoy working with Java and working with classes and objects, and you know, it's different. It's different from 120 and 224, 222, 121. It's different from the programming we do in most other classes up to this point. But once you kind of make this little mental adjustment to thinking of objects, it generally feels like the right way to be writing code for most people. And it's very hard to, you know, believe that you used to write code differently. And it kind of makes it hard to go back sometimes to writing C. All right, cool. That's all I got for today. So I will see everybody next time. I have office hours Thursday morning next, so you're welcome to come in there. Otherwise, I'll see you in class. Yeah, so someone said, it feels like with Java you spend more time thinking on the higher level of abstract data types rather than the specific syntax. This is definitely true. Java in this class is very much about, you know, I want to build a you know, such and such, and that's where you're going to spend your energy, is building the part that you want to create, instead of like, oh, first I have to make a string, which is a car star, and now I have to make a linked list and that kind of stuff. So our Lego blocks have gotten a lot bigger and a lot more fun, instead of, you know, working with little particles of plastic and shaping them together into blocks and then putting those together. So it's good stuff. All right, cool. We're at 3:10. I'll say have a great afternoon, and I will catch everybody next time. Thank you.
Thank you, Dave.
Or you can put 1 second on the ODP, like you said around the break time.
Yeah, we can. Hold on. Let me turn off my record.